Welcome to Pedigree Charts, Symbols and Problems. Here's some human pedigree chart examples. Pedigree chart, you might think, oh, that sounds like dogs, but no, it only means family tree. And it's a family tree to show the genetics of a family. And we're going to be using mostly human, but you could use dogs as well. Some pedigree symbols. A diamond is a gender unknown or non-binary. We've got male and female as square and circle. Parents mating is a line between two symbols, and mating of related individuals like cousins or second cousins, that would be a double bar. Children come down from a mating bar, and so this mating bar here would have a line coming down, and then you can have several children like this. Identical twins have a triangle with two of the same sex children, and fraternal can have two different ones or two the same. There's no triangle here. Deceased, you just put a slash through the person. And a few more. If it's shaded, it means they have the trait being studied. If it's not shaded, then they do not have the trait being studied. If it's half shaded, they can be carriers of the trait. It's not always used. Most often it's used if there is a codominant trait or if there's a sex-linked trait. Divorce / through the marriage line, and adoption is a dotted line to show that it's not a genetic child. How are these people related? Now, these are the generations: first generation, second generation, and third generation. And then these are the individuals: 1 and 2, 1, 2, 3, 4, and 1 of each of the generations. So let's take a look at the first one. Generation 1, number 1 and 2, unshaded, these are married. How about these blue guys down here? Okay, so we've got a circle, so that's a female, square's a male. These three are siblings. That means they're brothers and sisters. Just the blue ones, though, not the pink one. And their parents are the unshaded ones above. See, these are married and they have these 3 children. This pink one's not connected to the parents or to the children line. So let's look at the pink one. That's 2, 4. This pink one is married to number 3. Okay, so you can see the line between them. And guess what? Guess what number 1 is? It's their son. Now here's the thing. How are these 2 unshaded people related to the shaded boy here? Well, these 2 are grandparents of number 1 down below. And so he is the grandson of 1 and 2 up above. Not too bad, huh? Now we're going to talk about showing genetics. And here's an example. If a child, pink here, is recessive, they're little r, little r. We're going to use r's in this case. And they have to have gotten 1 R from mom and 1 R from dad. Now, the other letter could be another little r, it could be another big R, but if you have 2 little r's and you're the kid, you have to have gotten a little r from mom and a little r from dad. So mom and dad could either be dominant or they could be recessive. It depends on if they're colored in or not. Now, we don't have these colored in for traits. We just have them colored in to show you who we're talking about. So the pink one versus the green ones. Okay, let's try this one. If this yellow child is dominant, they could be big D, or big D, little d. And they have to have gotten this big D from either mom or dad. If they're big D, they had to have gotten a big D from mom and a big D from dad. But either way, they have to have at least 1 dominant parent. So one of these parents has to be dominant. Okay. Now we're going to go to a genotype and pedigree chart. And how do we figure out, just looking at the pedigree chart, if the shaded trait, because remember, If it's shaded, that's the trait we're talking about. If the trait is dominant or recessive, and we have two things we're looking for. There must be both parents with the same trait. So we're going to circle those in red. So this first one here, are they both the same parents with the same trait? They both are shaded, so that counts. These parents, are they the same? Yep, they're unshaded. They don't have the trait. How about these two? We got an unshaded and a shaded, so and then back to this one. This one has a shaded mom and a shaded dad and a shaded mom, and so they are the same. Mom and dad are the same, and mom and dad are the same here. Okay, but we're not done yet. Now we have to have the second thing, and that's they have to have a child. Those same parents have to have a child who's different. So we're going to do that in green, okay? So here's two of the same. They have a kid who is, the same as them, so that doesn't work. Two of the same, having a same kid. No, this one didn't work already. Let's go to the fourth one here. Two shaded parents have an unshaded baby. That works. And here, two unshaded parents have a different baby. There's a shaded. So these two are going to tell us something about whether or not shaded is dominant or recessive. Now, these would not be in the same pedigree chart. These are different pedigree charts. Okay, so what does this tell you? Let's take a look on the next page. So we're going to take a look. What do you know? First of all, could this baby be dominant? Well, let's try it. Can this be big A, little a, or big A even? Well, remember, if it's unshaded, the parents are different, so they'd be recessive. So they'd be little a, little a. Could this baby have gotten a big A from either parent? Absolutely not. So this baby could not be dominant. Therefore, the baby must be recessive. Well, let's check it out. So if we put a little b here, and now remember, the parents are dominant and he is recessive, but he has to have gotten a little b, one from dad and one from mom. So since he got one from each of those parents have to be heterozygous. And so the shaded trait is dominant. Because remember, we're not talking about the kid necessarily unless the kid was shaded in. We're talking about the one that's shaded. And we can see here that it doesn't work if it's recessive. It does work if it's shaded. When you have two different parents with a different kid, the kid is always recessive. The parents are always both heterozygous. Let's see if you can get that. So what do you say about this one? Is the trait dominant or recessive? And what about the parents? So first thing, kid must be recessive. The parents must be heterozygous. And so the trait is recessive. So we've got a little d here, big D, little d up here. And the trait, remember, is the colored in one. Since the baby must be little d, that is recessive here. So just because it's colored in doesn't mean it's dominant or recessive. It's when you have two of the same parents having a different kid. Let's go on. And here's some pedigree problem steps. Now this is if you're working out the whole pedigree chart. So first you find the recessive trait, just like we just saw. Then you label all of the recessive ones with little a, and all the dominants with one big A. Those two steps, easiest ones. Then you get down to the nitty-gritty. And the nitty-gritty says find all those dominant genotypes. If a dominant person has a parent that's recessive, then they are big A, little a. If a dominant person has a child that's recessive, they're big A, little a. Otherwise, we don't know. We put A dash, and just remember that A dash means we don't know what it is. So let's start with it. First, we're going to find the recessive trait. Two shaded parents that have a shaded baby. Well, here's two parents that are the same, but their babies the same as they are. So no. And then two unshaded parents that do have a shaded baby are right there. So here's two unshaded parents that have a shaded baby. They have unshaded babies too. Doesn't matter. If they have a shaded baby, that's what matters. So the same parents have a different kid, yes. And so all the shaded ones have to be recessive, little a, little a. And all the unshaded ones are dominant. So that one thing is telling you so much. It tells you that the kid is recessive, so all the shaded ones are recessive, all of them, and all of the unshaded are dominant. Let's label, that's on the next page. And so label all the recessive, little a, label all the dominant ones with one big A. Okay? So now we just have to get down to the nitty gritty. That's the third step. We've done the shaded, we've done the partially labeled, and now we're going to find those dominant genotypes. So let's start with the first one. Dominant guy here has kids. Are any of the kids little a, little a? This one here is. Therefore, he's big A, little a. Okay, how about this one? Does he have a parent that's little a? Little a? Well, absolutely, right there. So he's big A, little a. This one over here, or she's big A, little a. This one over here has children. We don't know who his parents are because they aren't on here, but he does have children who are little a, so he is big A, little a. And finally, here's one here and here's one here. They don't have any kids, not yet, maybe never, but not in this pedigree chart. But they do have parents. Do they have parents that are little a, little a? No, they don't. Therefore, we mark them with a dash after their big A. And that's it. A dash could be either big A, or big A, little a, but there's no way to tell here. Finally, polydactyly is an example. I like this. Here's this hand. If you notice, there's something a little bit different about it. They've got one thumb and then 5 other fingers. So they've got 6 fingers. Polydactyly means 6 fingers on a hand. It actually could mean 6 fingers, or not 6 fingers, 6 toes on a foot also. Dactyly is digits, poly is many, many digits. So here's 6 fingers on a hand. If you notice the pedigree chart, the trait is shaded here, and it runs in their family, right? Look at all of those. Now, you probably know that in our population, hardly anyone has polydactyly. You may know, I don't know anyone who has it, but I've had students who have. So there you go. Polydactyly, it's a thing, and but it's not very common at all. Can you tell from the pedigree chart whether or not it's dominant or recessive? No two parents are alike, so we cannot tell from the pedigree chart. You might want to guess that since there's hardly anybody out there in the population who has it, that, well, it's got to be recessive, but that's not true. Guess what? Polydactyly is dominant. Keep that in mind.